Well, I'll find out later if it's not in the right place. We'll figure it out. Okay, so we're talking about developing hypothesis. Now, in our organizational chart we did earlier, okay, goal of science, develop defendable arguments to explain the way the universe works, generating hypotheses, and then seeking evidence to support a hypothesis, okay? Hypotheses are like essential to the way science gets done, okay? It's the way that we are like making sure everything is on the up and up, that somebody's not snowing you about the findings of science, okay? Hypotheses are a statement. You're probably familiar with this already, that it's a statement. And what is it that you've been taught about what an hypothesis is? What's the definition of an hypothesis? Huh? Oh, come on now. Help me out here. What's an hypothesis? I know you know. What have you been taught up to this class about what an hypothesis is? It's still true. Educated guess? Really? Come on. Right? You've heard of that? Don't be afraid. All right. But an educated guess is not enough. You said testable, and it does say right here, okay, that it has to be testable. We talked about it already, test. All right? We talked about it last week when we were talking about this chart, that it has to be testable. All right? So it's not just to have an educated guess, but it has to be a statement that you can test. All right? And so that gives us a clue about the way it's constructed. All right? Now, what do you test? In fact, science has gotten pretty sophisticated in the way tests are done, but in high school we stick to the simplest of all tests, okay? And that's the independent and dependent variable. So first of all, we got to have a model, okay? Generating hypotheses from a model. Got to have a model. We have an idea of why it works. Now, a model can be a lot of different things. It can be a math statement, okay, that explains how one factor affects another factor, okay? Force equals mass times acceleration. Y'all remember that one from physical science? No? Yes. Okay, thank you. I'm glad you spoke up. All right. Well, that's a math statement. All right, that's what we're talking about. You have more than one variable that you're putting in an equality statement of some kind or an equation of some kind to say how one variable affects another. E equals mc squared. Y'all remember that? Heard that before? Okay. Well, that's a mass statement. Well, it's energy equals mass times the speed of light squared. C stands for speed of light squared. Speed of light in a vacuum. Okay? So it can be a mass statement. It can be a thought process where you think that if I feed we were talking about rats a while ago, testing with rats. If I feed my rats more and more salt, eventually some of them are going to die. Right? That's what we're talking about. What's the lethal dose of sodium chloride that a rat can ingest? Okay. So all of these things are models. Okay. Sometimes models are just organizational charts that explain how one thing affects another. All right. But it's a way of thinking about, a logical way of thinking about how things happen to make one thing affect another. Okay. Because we're only talking about two things here, independent and dependent variable. Now, that means you've got to limit all the other possible variables. Okay? If I want to test, as you're going to tomorrow, the density of a sample of a solution, and you want to so we can compare different concentrations in the densities, which is what you're doing tomorrow, okay? Then I'm going to change the amount of the salt I'm putting in the water and comparing those changes. Now, you're only doing one sample, and then we're taking the whole class's data and we're going to compare it as a class. Okay? So we're actually doing this independent and dependent variable stuff tomorrow. All right? But now, what would the model be? Let's say that we want to find out how changing the amount of salt dissolved in water affects the density. That's what we want to figure out. What's the model? What is the what can you? Now this is a creative endeavor. Okay, how many of you ever had to write a short story in an English class? Just make up one. Sure, everybody has. Come on, everybody raise their hand because everybody had to do this. Nobody has never written a creative story, right? Everybody has. I'm creative. Well, there you go. So you ought to be good at this. Well, see, this is all you got to do is apply that creativity to this process. Okay. Doing science is creative when you're doing pure science, particularly. Okay? So, what we have to do is say, okay, if I'm adding more salt to the water, how will it change the density, and why do I think it'll do it? Okay? So think about that a minute. How do you think adding more salt to water will change the density? Of the solution. So if I add more salt to water, will the density be greater or less? And why? Huh? Greater. Don't ask it in a question. It's greater, not greater? We're trying to write a statement, not a question here, okay? We're trying to get to an hypothesis, and that's a statement, not a question. All right? Too many people try to write questions. They're not questions. They're statements. Huh? Well, there's a question that's implied, but it's not a question. The hypothesis is a statement. Okay? So, you say it's going to increase the density as a statement, not a question. All right? Anybody have a different idea? Do you add more salt is going to decrease the density or increase the density? All right? Now here's the maybe hard part. Why? You're adding stuff into the water. Okay, so you're my chem babies. This is an elementary model here, okay? Or preschool model maybe. Okay? All right, her model is that the density increases Okay, hold on one second. The density of a saltwater solution increases as more salt is added because adding salt does what to the density? Huh? Okay, but how does it do that? How does it increase the density? We're just going to say because it adds more stuff to the solution? Huh? I heard somebody say something. Come on, speak up. Don't be afraid. Oh. Density is mass and volume, right? There you go. That's not bad. Okay? That's not too bad. All right, it could be more complex, and I would probably write a model that's a little more involved. But right now, this is good. All right? There's the model. All right, so what we have to figure out now is, from this model, how we're going to write an hypothesis. Before we can write the hypothesis effectively, we have to know what the independent and dependent variables are. Yep. No, this is not the hypothesis. This is the model. This is why it's going to affect the density. Okay? We'll get to the hypothesis. Work with me here, okay? Be patient. Okay, stay focused and be patient. Okay? Be determined. What? Be determined. This is the why part. This is the how part. That's the model. Or can be the model. All right? Okay. So this is why we think that adding salt to the water is going to increase the density. All right? Now, what is the thing that you are going to change in the experiment we're going to do? And what is the thing that will change because of what you changed? Huh? Okay. The mass will change, so that's what's going to be caused to change, or what you're changing. Okay. Everybody agree that we're changing the mass? Anybody think we're changing something else? Yeah. We're changing the density. Okay. Are you directly changing the density? What are you directly doing? What? Adding salt. That's what you're changing. Okay. You're thinking too far ahead. It's pretty straightforward and simple. The thing you change is the amount of salt in the water, right? All right. So that's the independent variable. Okay. The independent variable is what you directly change. in an experiment. Okay? In this case, you change the amount of salt. And I'm going to add a little more to it just to make sure it's clear, while keeping the amount of water the same. Alright? Because if you change the amount of salt and the water, you don't change the density. Okay? Density is an intensive property. Doesn't matter how much you have, the density won't change if you don't change the concentration. The way you change concentration is to keep the amount of water the same and increase the amount of salt. Or conversely, you keep the amount of salt the same and decrease the amount of water, you can change the density. Change the concentration. Okay? Got it? So by changing the amount of salt in the same amount of water each time, we're going to change the concentration of the solution. Okay? And what we're trying to find out in our experiment tomorrow is how does that change the density. And what we think is going to happen here, our model for this is that because we're adding more salt to it, we're going to increase the density. And what we want to do is see if it's true. Okay? Now, what's the dependent variable then? If that's the independent variable, you can directly change the amount of salt. What is going to be caused to change because we change the amount of salt? The density. We're assuming we're going to change the density. Okay? So the independent variable is what is caused to change because of the change in the independent variable. Independent variable is the amount of salt, and if we change the amount of salt without changing the amount of water, we're saying we're going to change the density. That's our dependent variable. Okay? And the cause of that change is what the model is. The model says, you said, it's going to be caused to change because we're changing the mass by adding more salt. That makes sense? Alright. Now, did one of you figure this out, or did it take the whole class to figure this out? Do you learn best by working alone or by working in groups? Hey, how many of you ever formed a study group? You want to do well in any class, you might think about forming a study group because other people. You ever heard the proverb, iron sharpens iron? No? Okay. I'm sorry. I go to church every Sunday. If anybody's not a Christian, that's fine. This is kind of like what my background is, all right? It's a Christian proverb, all right? It's in the Bible, okay? It means that one person working with another person makes them sharper, okay? Because you talk about things. You become smarter by talking to other people if you're talking about the right things. Okay? That's what it's referring to. Okay? It works in science too. Okay? If you're working with other people trying to solve problems, you'll get it solved probably more effectively and faster. Does that mean there's going to be arguments sometimes? Yeah. You get mad at people sometimes? Sure. But you got to be respectful. Okay? But you learn from each other. All right? So group 5 over there at table 5, they had a guy in their group right there that understood how to get things done, but they weren't working with him. They want to check with me, sure. Yeah, that's fine, which is okay. You can check with me, okay? But you got a tool right there. He's your tool. I don't want to say that in a bad way. He's the guy that kind of, he'll help you with part of it. You obviously understand something about density and measurement. You can help that group. You see what I'm saying? But so both of you, all three of you contributing together, are going to make it happen. But you got to learn to work with each other. You got to use each other's strengths. Got it? And strengthen the other people by your strength. You got that? Everybody brings something to the table. Literally, lab table. Okay? All right. Okay. Now, we've got an independent variable. So here is how we're going to build, and we got a model. Here's how we're going to build an hypothesis, okay?
How long does the hypothesis have?
There's no set length. All you have to do is meet the requirements. Okay? An hypothesis is hypotheses can be written without this form, but remember, you're my kin babies, okay? So I'm going to kind of give you kind of a real strict guideline here, okay, for chemistry in high school. Got it? All right? So we have to have an if-then statement. Okay, good. If I do this, then this is going to happen. All right. Imagine that. Look at all these connections here. Man. Okay. The if part deals with your independent variable. Okay? The if part deals with your independent variable. The then part is your dependent variable, dv. Okay? But then the structure of the hypothesis also has to have a, let's see, let me do it this way, a because phrase, and the because part of it, is the model. Okay? You have to have an if-then statement, you have to have a because phrase in your hypothesis. If independent variable, then dependent variable, because is the model. Okay? So just look up here at your independent variable, okay? And tell me, somebody, don't let me call on you. I mean, at this point, I'm trying to give you guys kind of a break. I'll start calling on people individually as time goes along here. I'll put you on the spot, okay? I've already put Zachary on the spot once, right? All right. I'll put some more people on the spot. Jose, I called on him one other day. Okay? I'll do that more. All right? But I'd like you to speak up on your own, okay? And share your strength with other people. Okay? So tell me, how do we say if about that independent variable? What do we say about if I do this? How do we use that? Yep.
If I put more salt in the water,
you're going too far. If I put more salt in the water. That's all there is. That's the if part. Okay? All right. Here's our if part. If I put more salt in an unchanging amount of water. So that's our if part. Okay, we're going to change the amount of salt and not change the amount of water. Okay? Somebody else. What's the then part? Yep. Then the density will change. All right. Now I want to kind of hold back on that a second because I got to have a because statement in there too. Okay. And I might put the because after the word then and before the rest of that part of that phrase, or I can put it after the whole phrase. Okay. So remember the then part is then the density will change. Why will it change? Okay, do you want to put the because after the then part then? How are we going to construct that back part? The then part. Then. Tell me how to say it. Oh, sorry. How am I going to construct the then part?
the density of the water will
Actually, once we put the salt in there, it's no longer just water, it's called a solution. Okay? The salt water solution. Or I could just say salt water. Alright, let's do that. The density of salt water will what? Increase. And what's our because part of it? The cause of it? Our model? Huh? Well, because adding salt is adding something that has more mass. Okay. Okay? Alright, so I'm going to color code a little bit.
So we have to do this every time we write a hypothesis.
You got it. You know now. You're expected to use it now. If I put more salt in an unchanging amount of water, that's our if part. Okay? Then the density of the water will increase. That's our then part of the statement, which is the dependent variable. Okay? And then we have a because statement down here, which is explaining why we think it will happen. That's our model. How we doing? You got a better grasp of how a hypothesis works? Can we test this statement? How? Duh, right? Okay, so we can test this statement, right? And that's what we said that hypotheses have to be. They can be tested. In fact, everything in science has to be testable. The word defendable up here in our goal of science. Defendable means testable. Okay, defendable means you have some evidence. Okay, and the majority of the evidence supports your argument. You got that? So testable is everything in science. If it's not testable, it ain't science. Got that? Alright? So let's say that I leave a cup of water on my kitchen counter, and the next morning I come in and part of the water is no longer there. Okay? Here's my hypothesis. You ready? You ready? Okay. Gremlins came in the night and drank part of the water. LOL. Okay. Can we test that?
Yeah.
We could stay up all night and watch for gremlins, I suppose, right?
We could do like the Wheat Thins commercial.
Okay. Like the Wheat Thins commercial, okay. But look. Supposedly, gremlins don't show up if you're there. Can we test it? They won't show up with their cameras. Huh? Is that a trap? They're too smart for traps. Come on, they're gremlins, right? That's not a. Is that a reasonable testable hypothesis? What would be a reasonable testable hypothesis? It evaporated. That's a good test. How would we prove that? How would we keep it from evaporating? Huh? Put a lid on it. So I have one cup of water without a lid, one with. See if that made a difference. And sure enough, it would probably tell us whether or not we had some evaporation or not. Look, hypotheses don't have to be right. More often than not, a real scientific hypothesis will be wrong. Got me? Probably need to write that down. More often than not, a real scientific hypothesis will be wrong. So for a real scientist, most hypotheses turn out to be wrong. What do you expect your hypotheses to be?
Right.
Well, if you're being a real scientist, you're probably going to have more wrong hypotheses than right hypotheses. It is just as good to disprove a hypothesis as to prove one. It is just as good to disprove a hypothesis as it is to prove one.
What did you say before that? That
Most hypotheses are going to be wrong. That's okay. It's just as good to disprove a hypothesis as it is to prove one. Got it?